Today we are going to look at solving area story problems, and we're actually going to look at story problems that seem very similar to the story problems we did with perimeter. The difference is that these are obviously area. They can be solved by any of the four methods that we've talked about for solving quadratics. Okay, the problem will be longer if you don't choose something that's super efficient. So if the quadratic formula is what you're always solving by, that's fine to still go with it. You just want to make sure you're choosing something that's efficient for you to try and make the problem as less lengthy as possible. So first of all, just some steps that I want to remind you of. We're actually going to use the same steps we used for solving the perimeter story problems in trimester 1, but that's been a minute, so I'm going to remind you. Our first step is that we are going to find the comparison phrase. And this is the phrase that will compare the length to the width, right? So it'll say the length is 4 feet longer than the width. The width is twice the length, whatever that comparison phrase is. Our second step is that we are going to define whichever comes second, either the length or the width. That's what all of these story problems will be about. So it's either going to be length or width. So if we literally physically read the word length second, we read width first and length second, we will define the length. Then we are going to translate that comparison phrase to define the other measurement. Okay, so if we define the width in 2, we will literally translate that comparison phrase to define the length. You're then going to plug into the area formula. Now, technically speaking, this could be the area of any shape. So this would work if it is the area of any shape out there, but everything we're going to be looking at is just going to be involving length and width. And the area formula then is for a rectangle, which will be area equals length times width. Sorry, this is an L for all of you know cursive. That's a cursive L. Then we are going to have to solve that equation. And then we are going to plug back in to find the other measurement. And right now that's not going to make a lot of sense, but it will in just a minute. So if we look at number 1 here, it is asking us to find the dimensions of a tall rectangular poster with an area of 10 square feet if its length is 8 more feet than 2 times the width. Right, so the first thing we want is that comparison phrase. So right here we see that the length is 8 more feet than 2 times the width. We are going to identify the length and the width in this phrase, right? So right here is the word length, here is the word width. The one that we read second, right? Length is first, width is second. Whichever one we read second, we are going to define first. So I am just going to let my width equal W. Now, you could let your width equals X. You could let your width equal whatever letter you choose. I don't think it would be wise to let width equal L, right? But you can let it equal whatever. Then we are going to translate this highlighted phrase. So I'm just going to use my key terms. I'm going to say my length. So I'm writing the word length. Is means equals. 8 more. So 8 more means 8 plus 2 times the width. So times is multiplication, 2W. Now, realistically speaking, it's more likely that we would write this as 2W plus 8. So that's the way that I'm going to write it. Our next step is that we now want to plug this into our area formula. So if our area formula for a rectangle says area equals length times width. Sorry, I always use a cursive L, so I know that confuses some of you. Right, my length is 2W plus 8. And I'm gonna multiply that times my width, which I said was W. I'm gonna set that equal to the area that it gives me in this story problem, which is 10. So this is something I can now multiply out. I can distribute my W. So that says 2W squared, right? W times W is W squared plus 8W. Now I think for most of us, we don't like it set up this way. We would prefer to see this set up as 2W squared plus 8W equals 10. Then you can choose to solve this by whatever method you want. Here, A doesn't equal 1, so I would think the majority of you are going to want to use the quadratic formula, which means we need it set equal to 0. Class, at this point, this solving portion is something we really truly should be able to do. Zoom this in a little bit more so you can see that better. Right, this solving portion is something we should be able to do. So I'm just going to plug this into the quadratic formula. You should be able to follow those steps. So if I'm plugging in, I'm saying A is 2, B is 8, C is negative 10, right? So I'm going in and I'm saying negative 8 plus or minus 8 squared minus 4 times 2 times negative 10 all over 2 times 2. If you think that you're like, what the heck, I don't know what's happening there, you probably need to go back and watch the video on the quadratic formula. Okay, so then we're going to calculate underneath the square root. So we'll get 144. That gives us 12. So we'll calculate both options. Negative 20 over 4 would be negative 5. Right, I never said these problems are short. So once you're here, you now have a decision to make. And this part is a little bit tricky, a little bit higher order thinking here. We have to recognize what we just solved for, right? Our variable in our equation was W. So we just solved for W. That means our width equals 1 or negative 5. But class, can a measurement be negative? Can I have a measurement of negative 5 feet? And the answer to that question is no. This is not a reasonable answer. Right? The only answer that makes sense is 1. So we are going to say that our width equals 1 foot. And then to find our length, we need to plug our 1 back in here. So we're going to say 2 times 1 plus 8, which equals 10. So our length is 10 feet. So our final answer will be that our width is 1 foot and our length is 10 feet. And that's kind of a lot all at once. These problems aren't short. So let's look at another one and go through it and see how it goes. Okay, so if we look at this next problem, the width of a rectangle swimming pool is 15 feet less than 3 times the length. So right there off the bat is our comparison phrase. Right, we're going to find that comparison phrase first. And we're looking to see where we read the word width and where we read the word length. So I'm reading length second, so that's what I'm going to define first. So I'm going to let my length equal L. And then I'm just going to translate this phrase. The width of a rectangular swimming pool means equals 15 less than. Remember, less than tells us to subtract and change the order. So I need to put that minus 15 second. 3 times the length. Right, so I now can plug this into an area story problem. I'm going to multiply my length times my width. And I'm going to set that equal to my total area because, right, area equals length times width, and it tells me the area is 42. This gives me an equation I am now able to solve, right? If I want to solve this, I'm going to distribute this L. So L times L is 3L squared minus 15L equals 42. My A does not equal 1, so most of us probably want the quadratic formula. So I'll have 3L squared minus 15L minus 42 equals 0. So I'm going to start plugging this into the quadratic formula. So the negative of negative 15 will be positive 15, right? Plus or minus negative 15 squared. Make sure that negative 15 goes in parentheses. Minus 4 times A times C is negative 42 all over 2A, right? So we're going to calculate underneath the square root. I'm just using my calculator too. I don't know that off the top of my head. We get 729. Class, before you start simplifying 729, check and see if it's a perfect square first. And this one is. So it's 15 plus or minus 27 all over 6. So we'll calculate both options. 15 plus 27 over 6 and 15 minus 27 over 6. 42 over 6, negative 12 over 6, 7. Now again, we need to decide what a reasonable option is. It does not make sense for us to say that a measurement is negative 2, right? It can't be negative 2 feet, negative 2, any measurement can't be negative. So this negative 2 is not a reasonable answer. We wrote this equation based off of L. So this 7 is our length. So we're going to say our length is 7. It was based on feet, so I'll say 7 feet. To find my width, I need to plug that 7 into what I defined my width to be. So I need to say 3 times 7, which is 21, minus 15, which is 6. So my length will be 7 feet, my width will be 6 feet. Okay, so on our next page, a plastic case that holds a standard CD has a length 4 centimeters longer than its width. So again, there is our comparison phrase. Has a length that is 4 centimeters longer than its width. It doesn't really matter that it's a plastic container. Do you guys even know what a CD is? Man, this is probably an outdated story problem. Okay, here is the word width. Here is the word length. So whichever we read second, we are defining first. So I'm going to let my width equal W. Right, my length is 4 centimeters longer. So longer is addition, so it's the width plus 4. So area says I'm multiplying these two together, and I'm setting that equal to the area in this story problem, which is 77. I now need to solve this. So to solve this, I'm going to distribute. W times W is W squared plus 4W equals 77. Now, my guess is that there's a lot of you who still want to solve this by the quadratic formula, but I know that's not all of you. I would solve this by completing the square. Right, so if you want to solve it by quadratic formula, that's fine. You start going quadratic formula, but I'm going to do completing the square. So I'm going to find B, take half of it, square it, add that to both sides. Right, I can factor the left, simplify the right, and then I start square rooting. We just have to remember the square root of 81 is plus or minus 9. Right, so that gives me two options, a positive 9 minus 2, which is 7, and a negative 9 minus 2, which is a negative 11. Again, we're deciding which answer is reasonable. It is not reasonable to have a negative measurement, so this negative 11 does not make sense. So I would say that my width is equal to 7, and the measurement in this problem is centimeters. My length is 7 plus 4, which is 11 centimeters. Number 4, find the dimensions of a rectangular table whose width is 2 inches longer than its length. Right, so there is our comparison phrase. Whichever we read second, we are going to define first. So I'm going to define my length as L. My width is 2 inches longer than its length. So I'm adding 2. So I'm now writing my formula. Length times width equals the area, which is given to me as 60. So L times L is L squared. L times 2 is 2L. All right, this is something that I can now solve. I just did complete the square on the last one, so let's go ahead and do the quadratic formula on this one. So I can find my A, B, and C. So I'm going to choose a different color here so I can keep track of everything. Right, my A is 1, my B is 2, my C is negative 60. But again, that piece shouldn't be an issue. We should be able to solve at this point. So we'll calculate underneath the square root. Right, I'm just typing it into my calculator too. Here's the catch. If we check the square root of 244, right, we get a big old long messy decimal. The square root of 244 is irrational. Here's where we have to make a decision. This is a story problem that is